Hello. Let's look at this question. Okay, a large set of okay a large vat is initially filled with a salt water solution. A solution with a higher concentration of the salt flows into the vat as the solution flows out of this at the same rate. Okay, the temperature, the number of the pounds of the salt in the vent at the time t minutes is modeled by the function of this. At t equals 10 minutes, the vent contains 50 pounds of salt. They ask you, write the equation of the tangent line, right? Of the graph of A when at the t equals what? 10, right? And the tangent line is approximately, use the tangent line to approximate the number of the pounds of the salt in the vent at the time t equals 12, all right? So when you have this kind of question, we generally do this way. We just assume this graph is any graph, okay? I put the graph just for the illustrative purpose. So this is the t, this is the a, the function. So this is the any graph like this. So we know at this point you have what? This coordinates will be 10, t equals 10, and this is 50. They ask you to find the tangent line of this passing through this point, okay? So what we're gonna do is, first, we need to find the slope, right? Slope, they told you, is this, right? That's the slope. So you can make what? A equals to 50. So you will find the slope of the tangent line at this point equals what? 6 minus 0 0.02 times what? A is 50. So if you do this calculation, you will find equals to 5. So we can write the equation right now. So we got a y minus 50, point slope form, okay, equals the slope is 5, and x minus 10, like this, right? So when you got this one, you can simplify further. So you can add 50 on both sides. You will get what? Y equals to this one times this one, that is a 5x, and the minus of 50, and the plus 50, like this. Huh? So you will get what? This one you can simplify, so y equals to 5x, like this. Now they ask you what's the t equals 12, right? So when t equals 12, so we got a y equals what? 5 times by 12 equals what? 60 pounds. That means you have 60 pounds of salt in the vat when the time equals 12 minutes, okay? So now let's go to the B now here. So when we do the B, let's look at it here, okay? I put it up. The B now here. The B, they said here, show that this one satisfies with differential equation of this with initial A10 equals what? 50. Eh? So what we need to do is this. You see here, this one equals to, this question, they gave you the solution already. They gave you this solution already. They just say verify if this one satisfies that. So what you need to do is you simply do derivative, okay? So you do dA and the dt. This one constant equals 0, and this is negative 250, and time by derivative of this. E derivative, so this part when you do derivative, you just keep it as what? 0.2 minus 0.02t. Because ex derivative still equals ex. But here we got, since we d to the t, so we got the chain rule. So you need time by derivative of this, which is negative 0.02t, like this. 0.02, no t. T is, get rid of that already. So you got this now here. And then if you do this calculation, so this one you time by this one, you will get, let me see here. So you have negative and negative is positive, so you have 250 times by 0.02, you got 5. So you will get what? 5, right? Time by e 0.2 minus 0.02t, like this. Now, when you got this one, right, and you need to what? Change this one to make sure this one is, so dt equals this already, right? And then let's look at this side here, this one, okay? This side, this one will be equals what? 6 minus 0.02 times a. A is what? 300 minus 250 times by e 0.2 minus 0.02t, like this, right? So that's the t. So when we have this, so I know the left side, this one equals this, we know that already. And I check the right side, okay? So when you do this one, the right side will be, this is 6, and this one times this one first. So you go 0.02 times by 300, you got 6. So this one is minus 6. And then this one times this one. Negative and negative is positive. You have what? 0.02 times by 250, you will get 5. You got a 5. And e 0.2 minus 0.02t. Now this is to cancel. So that means the right side of the differential equation equals this. The left side of the differential equation also equals this. So they're equal. So that means this one is the solution. Okay? But of course, this is one way, just verify. The other way is what? You just do the differential equation of the, solve the differential equation here. And then use the initial condition here to find exact solutions to this one, okay? Either way is fine. All right, so let's go to the C now here. So when you look at the C, you see here, so I'm going to show the C with the other video, okay? The following video, because the time is limited here right now. It's not enough time to finish this one within 10 minutes. All right, so if you have any question for this part here, actually the A and B is easy here. We got it already. So we just find out this one to find the tension line and use the tension line to approximate when t was 12, just plug it in. And this part we just what? We just go by plugging. This is the function we found already. We just verify the left side of the differential equation equals the right side of the differential equation. Okay, we just did the differential equation here. Got this one and this one. Of course, we use the chain rule here. All right. So if you have any questions, please let me know. I'm going to continue with the question C with the other video. Thank you. Bye-bye.